Alexa, what are you doing? You're late.
What are you doing here?
Let's face it, you're gonna need a lot of help if you're gonna get through this game.
Alright.
Well, first you have to get out of the car to start the pregame.
Okay, but first, let me get a cold one.
No, Alexa, not that type of pregame!
Just chill, it's just water, man.
Just get out of the car, we need to start. Alright, let's start by doing some stair running. But first, a quick physics lesson. As Alexa runs up the bleachers, she is actually doing something called work. Much like the powerhouse lab we did in class, we calculated the number of watts she has by dividing the amount of joules by the amount of time it takes for her to run up the stairs. Alexa does work as she runs up the stairs, as she is doing work against gravity to gain GPE. The rate at which the work is transferred to GPE is called power. We can represent power by this equation. Let's say her GPE is 638.8 joules. And let's say it takes her 3.8 seconds to run up the stairs. We can plug these values into our equation and we get a total of 168.1 watts. Alright Alexa, it's time to practice hitting some balls.
Alright, let's go over.
How long have you been playing this sport for?
Very funny.
It wasn't a joke.
Yes, I hit it this time.
This seems like the right time to teach another physics lesson. Let's talk about something called kinetic energy and gravitational potential energy. Two energies the ball has as it flies through the air. As it flies through the air, the softball has kinetic energy, which essentially means that the softball has energy because it's moving. The softball also has gravitational potential energy, which is energy stored from a change in position. The thing about energy is that it cannot be created nor destroyed. It can only be transferred from one form to the other. Let's calculate the KE of the softball as it flies through the air. First, we need to pick some values. Let's say that our softball has a mass of 0.50 kilograms. And after it is hit, it has a velocity of 4 meters per second. We can plug this information into a given equation for finding KE. Our given equation is KE equals 1/2 mv squared. So if we plug our numbers in, we have KE equals 1/2 0.50 kilograms times 4 meters per second squared. Next, let's write our equation for gravitational potential energy. The mass will always be the same at 0.50 kilograms, and G will always be the Earth's gravitational pull at 9.8 meters per second squared, and we will say that the height at the top will be 30 meters. The given equation for GPE, and if we plug our numbers in, we will get our two equations. These are two equations you can use to find the KE and GPE of a flying softball.
Whoa, it's actually going really far. Whoa, it went over the fence!
Okay, I guess you could run the bases if you would like, but I need to teach another lesson real quick.
Oh, not again.
Let's reflect back to when Alexa hit the softball. Newton's third law states that for every force, there's an equal and opposite force. In this example, Alexa swings the bat, and the bat applies a force on the ball. But according to Newton's third law, the ball also applies the same force but in the opposite direction to the bat. All right, Alexa, finish running the bases. Oh no, Alexa, slow down! Oh, Alexa, what did I tell you?
Oh.
Well, I need to teach another lesson, so get up. Let's take a quick look back to when Alexa was running the bases after her home run. As Alexa is running, she has momentum, or the quantity of motion of a moving body. Let's calculate her instantaneous momentum after she rounds third base. The equation we use to solve for momentum is P equals mv. This is to solve for instantaneous momentum. Let's say Alexa is moving at a velocity of 7 meters per second, and that she weighs around 54 kilograms. We can then plug these numbers into our equation, and her instantaneous momentum, after rounding third base, is 378 kilograms meters per second. Momentum. After Alexa reached home plate, she had 2 momentum and wasn't able to skid to a stop quickly enough before she collided with the fence, creating an inelastic collision. This is an inelastic collision because 2 objects collided and stuck. We can calculate Alexa's final velocity after she hit the fence by using an inelastic equation. We can plug in some values. We then get these values. And our velocity final comes out to be, once again, this is an inelastic collision, as when Alexa hit the fence, they both stuck, but the fence moved inward with Alexa at 5.1 meters per second. Okay, Alexa, I think you're sort of ready.
Really? Okay.
What time does your game start?
3.
Alexa, it's 5:30.
Oh, God.